For section 1, 2, we are going to move on to data, sampling, and variation in data and sampling. So first of all, again, some terminology. A quantitative variable, and if you remember, we talked about quantitative in the last section. That means you're dealing with numbers, and math is significant when you deal with those numbers. But a quantitative variable is said to be, number one, a discrete variable if it has a finite or a countable number of possibilities. And then being countable means that you're counting in the natural numbers, so like 0, 1, 2, 3, 4, 5, and so on. Typically, these variables are exactly that. They are counts. It's typically where you're counting something, and that is going to be a discrete variable. The second type of quantitative variable is a continuous variable, and this is if it has an infinite and not countable number of possibilities. Infinite but not countable number of possibilities. And typically, these variables are variables that are measurements. So the two types of quantitative variables are the discrete ones, where typically you're counting something, and then continuous, where typically it's a measurement of something. So example 1.6, using our last example, we want to classify each of the following quantitative variables that we identified in our last section, and we're going to identify them as discrete or continuous. So letter A, the number of children in the family, that is going to be discrete. And it is discrete because you can see very clearly that's going to be a count. You are just going to count how many children they have. They have 0 children, or they have 1 child, or they have 2 or 3, or so on. Letter B, household income in the previous year. This one could be a little bit tricky. It might seem continuous, but I would say that this one is probably discrete again. And the reason I'd say it's discrete is that you're counting the amount of money, and it's not a measurement of something where you can be more and more precise. It's just you have this much income in the household. So that one would also be discrete. Letter C, the daily intake of whole grains, and there's a key word, measured in grams per day. When you are doing a measurement like that, the idea is you can be more and more precise. So it may be 5 grams, but maybe you measure more precisely and it's really 4.9 grams, or maybe you measure even more precisely and it's 4.93 grams, and so on. And the idea is, if you want to measure something more precisely, if you have the correct tools, you can measure them more precisely. So that one ends up being a continuous variable for part C. The list of observations that a variable assumes is called data, and we talked about that in the last section. Qualitative data comes from observations that correspond with a qualitative variable. So our last set of terms was a qualitative, talking about qualitative variables, in the last section, talking about qualitative variables and quantitative variables. Well, qualitative data comes from those qualitative variables. Then we have quantitative data, and those are observations that correspond with quantitative variables. So qualitative data comes from observing qualitative variables. Quantitative data comes from observing quantitative variables. Discrete data, as you may guess, those are going to be from observations corresponding to a discrete variable. And so again, that's under the quantitative category, but it's a specific type of quantitative. It's discrete. And then again, similarly, continuous data, that's going to come from observations corresponding to a continuous variable. So remember, the data is the observations. The variable is just what you're observing. Example 1.7, you go to the supermarket and you purchase 3 cans of soup. There's 19 ounces of tomato bisque, there's 14.1 ounces of lentil, there's 19 ounces of Italian wedding. Then you're going to also get 2 packages of nuts, walnuts and peanuts. There are 4 different kinds of vegetables, broccoli, cauliflower, spinach, and carrots, and 2 different desserts, 16 ounces pistachio ice cream and 32 ounces of chocolate chip cookies. Name the data sets that are quantitative, discrete, quantitative continuous, and then also qualitative. So let's start with quantitative discrete. Remember, quantitative discrete is basically counts of things. So there are a couple different spots here where we maybe have that. 2 packages of nuts, 3 cans of soup, depending on how we're setting up our situation there. 4 different types of vegetables, different kinds of vegetables. 2 desserts. These are all those things that are countable, so those red underlined ones could qualify as quantitative discrete depending on how you're setting up your study and what your variable is. Then we have quantitative continuous, and we will take care of underlining those in green. So quantitative continuous, remember typically these are measurements. So when you see things like 19 ounces of tomato bisque, 14.1 ounces of lentil, 19 ounces of Italian wedding, those are measurements, along with your 16 ounces of pistachio ice cream and 32 ounces of chocolate chip cookies. So those ones underlined in green, again, depending on how you were setting up your study, those could be quantitative continuous. And then finally, we're going to do qualitative. I'll underline those in blue. Qualitative, remember, means that you have categories. So things like walnuts and peanuts, that was the 2 different packages of nuts that we had. The different kinds of vegetables, broccoli, cauliflower, spinach, carrots. You're separating them into groups based on their qualities. It has nothing to do with measuring, has nothing to do with numbers. It's just what type of category they would fit into. So again, some of that depends on how you are setting up your study, but in general, that would be your 3 different types of data sets that you'd have for that example. In a pie chart, we're going to talk about some different types of pictures that we can use. In a pie chart, categories of data are represented by wedges in a circle and are proportional in size to the percent of individuals in each category. The idea behind a pie chart is we're going to compare the parts to the whole usually, or maybe one part to another part in our pie chart. A bar graph is appropriate to compare the relative size of the categories with categorical data. So we're going to have categorical data there, and we can make a bar graph that represents those things. And again, we're comparing the size. So let's take a look at an example of this. We've got our 2 colleges here, De Anza College and Foothill College, and you can see we've got a table that shows us the full-time number of students, the part-time number of students, and then the total number of students, along with the percentages for each of those schools and each of those categories. So if you look here, first of all, at this pie chart over on the bottom left, we've got the De Anza College pie chart, and you can see we've got 59.1% of the students are part-time and 40.9% are full-time. Then if we look over at the Foothill College pie chart, we've got 71.4% of students are part-time and 28.6% of the students are full-time. Now, in comparing these, when you look at them, we can see for De Anza College, it's about 60% of the students are part-time and about 40% are full-time. If we look at Foothill College, you've got about, almost 3/4 are part-time and about 1/4 is full-time. What we cannot do, so we can compare them to each other, parts to the whole or whatever, but what we cannot do is it would not be a good idea to try and compare this to this. So the part-time students in De Anza College compared to the part-time students in Foothill College, from our pie chart, it would look like Foothill College, since it has a bigger percentage, probably has more part-time students than De Anza College. But if we look at the actual numbers, De Anza College has 13,000 part-time students and Foothill College only has 10,000. And the reason that that's not appropriate is because you're comparing each individual part to its individual whole. And so you don't want to compare them one to another when you're talking about a pie chart because the totals are different for each of those. Now going over to the bar graph, then it's a little bit more realistic and we have the ability to compare them. If you were doing that same comparison with our part-time students from each of those colleges, you can see that the De Anza College definitely has more part-time students than the Foothill College. And so then you can compare one college to another in this case, or one group to another, rather than just a part to the whole. So each of those has a different set of characteristics which makes them useful in different situations. Moving on to sampling, we want to start talking first of all with random sampling. Random sampling is the process of using chance to select individuals from a population to be included in the sample. So random meaning, I had somebody talk about this, means kind of like sporadic, and that's kind of the idea. Sporadic values, everybody has a chance of getting chosen. A sample with size n, lowercase n, sample size, from a population of size uppercase N, capital N, for the population size, is obtained through simple random sampling if every possible sample of size n has an equally likely chance of occurring. So the sample is then called a simple random sample. And that, again, that means every every sample of size n is equally likely to be chosen. Simple random sampling does require that we have a list of all the individuals within a population. And just a little note, individuals doesn't necessarily mean people. It just means items that are being considered in the population. This list is called a frame. So the frame is the list of all the possible items in the population. If we do not have a frame, if we don't have that list of all the possible items in the population, then we have to use a different sampling method. We cannot use the simple random sampling. Example 10, suppose that a study group consists of 5 students, Bob, Patricia, Mike, Jan, and Maria. I keep forgetting to change this in my master copy here, but we're going to change Mike's name here. We're going to say that Mike's name is actually Dan, and that's just going to be for us so that we can write it a little bit more easily. 2 of the students must go to the board and demonstrate a homework problem. List all the possible sizes, all the possible samples of size 2 without replacement, which means an individual who is selected is then removed from the list and they are not going to be chosen again. So the same person doesn't have to go to the board twice. It's always going to be 2 different people. So the way we can do this, to list all the possible samples of size 2, I'm just going to use the first letter of their name. But let's say that Bob is chosen. Who else could go with Bob? Well, it could be Bob and Patricia. So that's one possible sample of size 2. Or it could be that Bob gets chosen and then also Dan gets chosen. That would be another one. It could be possible that Bob gets chosen and then Jan gets chosen. And then also Bob could be chosen, and the last option, if Bob is chosen, is maybe Maria gets chosen to be the other person who goes up to the board. So those are all the different samples where Bob gets chosen. Now we want to continue because we're trying to write down all the samples, samples of size 2. So let's say that Patricia gets chosen, and let's do all the ones where Patricia gets chosen. Well, Patricia has already been chosen once with Bob. So we're not going to include that one again, but Patricia could also be chosen, and then Dan could be the other person. Or Patricia could be chosen, and then Jan could be the other person who gets chosen. Or Patricia could get chosen, and then Maria could get chosen. So that is, including the one option from the first line there, those are the 4 different samples that could have Patricia in them. If we go on, let's see, Bob, we've taken care of Bob, we've taken care of Patricia. Dan. So we could say, when will Dan be chosen? Well, we've already had Dan with Bob and Dan with Patricia. So that's 2 times, and chances are we should have 4 again. So we also need to have Dan getting chosen with Jan and Dan getting chosen with Maria. So those would be all 4 times, including the 2 from before, where Dan gets chosen. So we've done Bob, done Patricia, got Dan taken care of. Then we're going to have Jan. Now we do want to remember also, Jan has already been chosen with Bob and with Patricia and with Dan. So the only other person that Jan can be selected with would be Maria. And that would be her 4 samples. And then finally is Maria. And Maria gets selected with Bob, with Patricia, with Dan, and already with Maria. So she's already had all of her different samples that she's included in, written down in our list. So if we look at this list, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different samples of size 2 where we're looking at who could be chosen. And remember that in order to be able to do this random sampling, if we were choosing a random sample, you do have to have this list of all the possible individuals, and remember that is called a frame. So you've got to have the frame, and then you can list out all those possible samples, and you can see that each of those samples, since there are 10 of them, if you were choosing randomly, each of those samples would have 1 chance out of 10 of being chosen. Steps for obtaining a simple random sample. First of all, we do have to list all the individuals in the population of interest. Then we would number those individuals in the frame 1 through n. Remember, the frame is just that list of all the individuals. And then after that, we use a random number table, a graphing calculator, or statistical software to randomly generate n numbers, lowercase n numbers, where lowercase n is the desired sample size. So after we have a list of everyone, let's say it's people in our class, if we list all the people in the class and we give each of them a number, 1 through however many people are in the class, and let's say I want to sample half of them, well, I would choose half of those random numbers out of a table, and whoever's name matched up with the corresponding number, those would be the people that I would sample if I was doing a random sampling from our class. Now, because we don't always have a frame or a list of all the individuals in a group, we have to have some other types of sampling methods. So we're going to go through those now. The first type we're going to talk about is what is called a stratified sampling. And a stratified sampling has a couple of characteristics that we want to focus in on. The population is divided into a number of subgroups. So our population is divided into a number of subgroups, which are called strata. And then random samples are taken from each subgroup with sample sizes proportional to the size of the subgroup in the population. So the key here is you're dividing your population into groups, and then you are doing random samples from each group. So every group is represented. Now, the number of samples that you take from each group is dependent on how big. So a bigger group, a bigger strata would get more sampling from it. A smaller strata would get less sampling. The second type we want to talk about is quota sampling. And this is a variation of stratified sampling where you still divide them into subgroups, but samples are collected in each subgroup until you get the desired quota. So let's say that your subgroups are people whose income is greater than $50,000 per year, and then people whose income is less than $50,000 per year. And you, whoops, I put greater than twice. Let's fix that, less than. And for some reason, you have decided that you want to have 14 people surveyed out of this group, and you want to have 36 people surveyed out of this group. And so you're just going to keep randomly sampling from each of those groups until you get 14 from the 36 from the first group and 14 from the second group. That's quota sampling. Quota sampling is the idea of you want to meet a certain quota, a certain number of something in a group. The next type we're going to talk about is called cluster sampling. So once again, cluster sampling, we still are going to divide our data into subgroups, or not our data, but our population into subgroups. This time they're called clusters. And the difference here between stratified and cluster is what you do is a set of subgroups are selected to be in the sample. So you're not sampling from all the subgroups, you're picking just a group. Remember, a set means a group. You're picking a group of those smaller groups to sample. So let's say you had 5 different subgroups. And in stratified, you're going to talk to people in each of these different 5, but you're not going to talk to everybody. In cluster sampling, you're going to maybe choose this one and this one, but you're going to talk to everyone in those 2 groups. Okay, you're not going to talk to all 5. You're not going to talk to people from all 5 groups, but you're going to talk to everyone in those 2 groups that you have chosen. So that's the difference between stratified and cluster sampling. Then we have systematic sampling. That's when every nth member of a population is selected to be in the sample. This is kind of like when you were maybe in elementary school and you would number off for teams in gym class or whatever, and you're like, oh, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and then it was, oh, all the 3s are going to be in this group, and all the 1s are going to be in this group, and so that's kind of like systematic sampling. In that case, you'd have every 4th person was chosen to be in group 3, or every 4th person was chosen to be in group 1, and that is an example of systematic sampling. We also have some other types that maybe are not the best options, but convenience sampling is when samples are chosen by selecting whoever is convenient. An example of that would be if I'm going to sample the students from the school, if I'm trying to gather information about the students from the school, and I choose as my sample just the people who are in this class right now. That would be convenience sampling. Just who's right at hand that we can talk to. Another option is voluntary response sampling, and this is where we allow the sample to volunteer. And so it doesn't mean that we're going out and choosing people, we're just allowing people to volunteer. Example 112, in each case indicate the sampling method. Part A, every 4th person in the class was selected. So, and I kind of gave this one away. Every 4th person in the class is selected. That's going to be the systematic sampling method. Next, for B, a sample was selected to contain 25 men and 35 women. Well, the sample was selected and it needed to contain those people, and so that is a quota. You had to keep sampling until you got your 25 men and your 35 women according to that particular sample. Letter C, viewers of a new TV show are asked to vote via the TV show's website. This is probably a combination one. I think most basically this is a volunteer sampling. Could also be, as a subscript there, kind of convenience. You're not doing any work to go out and get other people. You're just going to sample the viewers of your TV show on the website. Okay? And so, but I think in general, your main answer there would be that it's volunteer. Letter D, a website randomly selects 50 customers to send a satisfaction survey to. Again, You might have a random sampling idea, but most basically this is volunteer again. Because are the people required to return that satisfaction survey? And the answer is no. Most of us, when we get surveys like that in the mail or on a website, we are going to toss those in the garbage or just ignore them. So that's another volunteer option. Letter E, to survey voters in a town, a polling company randomly selects 10 city blocks and interviews everyone who lives on those blocks. So the idea is they've made subgroups, and the subgroups are the blocks that people live on. So you're looking at your subgroups are the blocks. Now here's the key. They're selecting 10 blocks and interviewing everyone who lives on those blocks. So they're not sampling from all of the blocks in the city. They're just choosing those 10 and talking to everyone who lives in those blocks. So that is the cluster sampling. Okay. Again, the way that differs from stratified, if they would have talked to 10 different people who lived on from each city block, that would be stratified sampling. But in stratified sampling, you have to randomly sample from each group that you've divided them into. You're not talking to everybody from just a few groups. Some steps for obtaining a systematic sample. Number one, if possible, we want to approximate the population size, and that is capital N. Then second, we want to determine the sample size that is desired, and that is lowercase n. Then we're going to divide them, capital N divided by lowercase n, and we round that down to the nearest integer. This is the value that we're going to call K. And so K tells us how often we're going to select a person. In our example of gym class, it was every fourth person. Number 4, randomly select a number between 1 and K, and we'll call this number P. So again, in my gym example, I chose the third person, and I went, okay, 1, 2, 3, 1, 2, 3, 1, 2, 3. Well, that means it was the third person, and then plus 4 would give us, or 1, 2, 3, 4, I guess is what I was doing. Then the 7th person, and then the 11th person. So we started with the third, then we added 4 to get to the 7th person. We added 4 more to get to the 11th person. And you know how we used to do that. We tried to arrange ourselves that we were exactly 4 people apart, so we'd get on the same team as our friend or whatever. So the sample consists of that, and then by the time you get to the end of the group, numbering that 1, 2, 3, 4, 1, 2, 3, 4, you will, in theory, have your n number of people in your sample size. And the reason that becomes important is later on in the year, we're going to find out that there are certain times where you want to have at least a certain number of people in your sample to make your results as valid as possible, as accurate as possible. One thing that happens is variation is present in any set of data because not everyone is always the same, and not every object is always going to be the same in your groups. So for example, 16-ounce cans of beverage may contain more or less than 16 ounces of liquid. In one study, 6 16-ounce cans were measured and produced the following amount in ounces for the beverage, and the results are listed here. Now, the reason that this becomes important and the reason that people might be concerned about this is if a company is producing these cans of beverage and all the cans are holding more liquid than they're supposed to, what happens in that case is the company is going to end up losing money because they're giving away more liquid than they're supposed to in their beverage cans. On the other hand, if the cans consistently, like in this case, they pretty consistently have less and sometimes a lot less than the 16 ounces that they're supposed to have, if customers find out about this, they're going to feel like they're getting ripped off. So companies will check these things fairly frequently just to make sure that they are staying really close to the amount that's actually supposed to be in their product and the weights and ounces and stuff like that. So measurements of the amount of beverage in a 16-ounce can may vary because different people took the measurements, or because the exact amount, 16 ounces of the liquid, was not put into the cans, and that's that idea of variation. They're not all going to be exactly the same. Manufacturers do regularly run tests to determine if the amount of beverage in a 16-ounce can falls within the desired range, and we already talked about why that's important. You don't want to have too much in those cans, or you're going to lose money if you're a company, and you don't want to have too little, because then you're going to lose customers. They're not happy, and you're going to lose money also. So it's they're trying to keep it as accurate as possible. The natural variation of samples is called sampling variability. This is unavoidable and is expected in random sampling, and in most cases, this is not an issue. It can become an issue if it's really drastic, but in general, you're going to have variation, and it's not a problem. So, for example, if we repeatedly take samples of 1,000 people from a population of likely voters from Washington State, some of these samples might have a slightly higher percentage of Democrats or Republicans than the actual amount in the general population. So again, the variation comes when the samples differ from the actual amount in the population. That is the variation. Now, does that matter? No. You might also have a situation where other samples might include more older people than there are in the general population, or more younger people than there are in the general population. And again, this is just called sampling variability. It's not a big deal. It just happens when you take these samples, even if they are random samples. So, common types of bias in sampling. Now, I do want to mention here, when we talk about bias, when we use that word in normal language in English, typically means something bad. Oh, you're biased against someone, and so you're not giving them a fair deal or whatever. Bias in sampling is a little bit different. It just means that it doesn't mean you did anything wrong. It doesn't mean that it's bad. It just means that whatever you're dealing with, your sample that you take, doesn't match up with the population perfectly. So it's going to happen most of the time, but that's what bias means when we're talking about sampling. So again, sampling bias, it's a sample that is not representative of the population. We kind of mentioned that a little bit before. Voluntary response bias. This is a type of sampling bias that often occurs when the sample is made up of volunteers. A reason for that could be if you are going to volunteer to be part of a sample, a couple things could be true. Maybe you have really strong feelings about a certain topic and you want your opinion to be heard. Maybe you just want to complain about it. Maybe you just are bored. And so your response may or may not be, or those responses altogether may or may not be a good representation of the population as a whole. It could be a self-interest study, sampling bias that occurs when the researchers have an interest in the outcome. If you are researching something and based on your research, you're trying to sell a product, that could be a situation where you've got a self-interest study going on, and so whether you're trying to or not, you might be biased with the results because it's going to help you sell something. Response bias. This is a sampling bias where the responder gives inaccurate responses. So they respond, but for some reason they respond inaccurately, maybe on purpose, maybe not on purpose, but they're giving wrong, inaccurate responses. One type of this would be perceived lack of anonymity, a sampling bias where the responder fears giving an honest answer because his or her response might have a negative effect. So for instance, let's say that somebody was taking a survey of their employees about the boss's job performance, and let's say the people didn't know, maybe the boss was going to see these results and find out what they said about their boss, and they might not give honest answers because they might be worried if the boss finds out, I think he's not doing a good job or she's not doing a good job, I might get fired or I might get penalized or something. That would be a perceived lack of anonymity, and that would cause that response bias. You might have loaded questions in your sampling. This is sampling bias when the wording of the question influences the responses, and I'll just give you a really obvious one. Let's say that you're doing that survey about your boss, and one of the questions is, tell us why your boss is the best boss in the world, or why he's the worst boss in the world, or she. And so that's a loaded question. You are kind of pointing the answers in one direction when you ask a question like that. So that's an example of a loaded question. And then there's non-response bias. That's a sampling bias where people refuse to participate in the study. Again, that can happen. That's kind of related to that voluntary one. So if you have the choice to respond or not, and maybe a lot of people choose not to, so you're not getting their perspectives or their information, their input in your sample, you're only getting that certain group that's willing to respond. That is the end of section 1.2. There are 14 graded problems there. Again, it's going to be a lot of identifying the type of sampling methods, discrete, continuous type of variables and data, and all those different types of things that we talked about with the terminology here in section 1.2.